Okay, let's dive right into what I honestly think is the ultimate existential mystery. We're going to explore the fact that our entire universe, literally everything you see, touch, and experience, is basically just a microscopic mathematical remainder. And to truly understand how we know this, we have to perform an autopsy on some of the absolute wildest physics of the 20th century.
1 billion. Try to picture this. Right after the Big Bang, the universe was this unimaginably hot, dense soup. And in that primordial soup, for every 1 billion matter and antimatter pairs that violently obliterated each other, exactly one particle of matter somehow survived. Just one.
That virtually invisible, microscopic sliver? Yeah, that represents every single galaxy, star, planet, and person in existence today. The rest of it, completely annihilated into pure energy. So, how on earth did physicists actually figure this out? Well, it all started with a man who was, honestly, just playing a game of mathematical aesthetics. Our main suspect in this mathematical autopsy is a physicist named Paul Dirac. And Dirac was, well, he was a uniquely fascinating guy. He was so notoriously detached from small talk and socializing that his colleagues jokingly invented a brand new unit of measurement called 1 Dirac. It was strictly defined as speaking exactly one word per hour. I mean, the guy simply didn't speak unless it was absolutely mathematically necessary.
He famously said, "It is more important to have beauty in one's equations than to have them fit experiment." Think about that for a second. He wasn't even trying to discover antimatter. He was obsessively trying to fix equations just to make them mathematically beautiful, treating physics almost like a giant puzzle. He was fixing the math just in case it ended up describing reality.
So, the massive crisis he was trying to fix came to a head in the late 1920s. On one hand, you had Einstein's theory of relativity, perfectly describing objects moving at super high speeds. On the other hand, you had Erwin Schrödinger's quantum mechanics handling the tiny, weird world of subatomic particles. The big problem? Schrödinger's math completely fell apart if those tiny particles were moving really, really fast, and Dirac wanted to unify them.
Because Schrödinger's equation simply couldn't handle relativity, other physicists pitched the Klein-Gordon equation, but it had a glaring glitch. Because of the way they squared the time derivatives, the math began spitting out negative probabilities. And as Dirac quickly pointed out, the chance of finding a particle somewhere literally cannot be less than zero. That's just physical nonsense.
So, Dirac insisted on building a purely linear equation, one completely without those problematic squared time derivatives. To balance everything out, he essentially had to find these mysterious, unknown coefficients he called alpha and beta. Sounds straightforward enough, right? Just a standard set of simultaneous equations to solve.
Well, here's where he hit a massive brick wall. If you try to plug standard numbers into these coefficients, like, say, a 1 and a -1, the math will only ever equal a +2 or a -2. It absolutely refuses to balance out to zero. And why? Because regular numbers just do not care about the order in which you multiply them. A times B is always going to be the exact same as B times A.
Taking a cue from his highly outgoing friend Werner Heisenberg, who, by the way, was literally the polar opposite of Dirac, Dirac realized he needed a totally different kind of math. Enter the matrix. Now, a matrix is basically an array of numbers representing transformations. And the magic of matrices? The order of multiplication actually matters. A times B does not necessarily equal B times A.
Initially, Dirac tried using standard 2x2 matrices, but they just couldn't satisfy all the coefficients he needed. So, he has this stroke of absolute genius. He uses a 4x4 matrix hack. By jumping up to 4 rows and 4 columns, suddenly, miraculously, all the math worked perfectly. The equation finally balanced.
Schrödinger's old equation relied on a single wave component. But to pull off these new 4x4 matrices, Dirac had to upgrade the wave function itself to have 4 distinct components. And in doing so, he created an equation that treated space and time symmetrically. It was astonishingly beautiful.
Now you'd think the physics community would throw him a parade, right? Nope, they had an absolute meltdown. Werner Heisenberg actually called Dirac's beautiful math the saddest chapter in modern physics. The smartest people on Earth were completely losing their minds over this. Wolfgang Pauli even threatened to quit physics entirely and go write utopian novels. No joke. This massive panic was caused by a glitch baked right into this beautiful new math. The equation didn't just spit out normal positive energy, it spit out negative energy solutions. It basically implied that an electron could continually radiate energy and fall forever into an infinite, bottomless negative abyss.
To classical physicists, this was just completely absurd.
But Dirac, stubborn as ever, defended his just-in-case math. To patch the glitch, he proposed an incredibly wild concept, the Dirac sea. He theorized, okay, maybe we don't fall into the abyss because the vacuum of space is actually an infinite sea already completely filled to the brim with invisible, negative energy electrons. Since the sea is full, normal electrons literally can't fall in.
Then, he pushes this crazy model one step further. He predicts that if you somehow knocked one of those invisible electrons out of the sea, it would leave a hole. And to us sitting here in the real world, that empty hole would appear as a completely new, unobserved particle, an anti-electron. Basically, a twin to the electron, but rocking a positive charge.
And this leads to the ultimate vindication of Dirac's obsessive quest for beauty. Think about this timeline. In 1928, he gets laughed at for his 4x4 hack. In 1931, he doubles down and predicts the anti-electron. And just 1 year later, in 1932, a guy named Carl Anderson is looking at cosmic rays and accidentally discovers the positron, which is the exact anti-electron Dirac predicted. Mathematical beauty literally predicted physical reality before we ever had the tools to see it.
So now we can finally see the true payoff of that 4x4 matrix hack. Remember those 4-wave components? They map to reality beautifully. The first two components represent the two spin states, up and down, of regular matter, the electron. And those remaining two components, they perfectly describe their antimatter twins, the up and down states of the positron.
Eventually, the physics world realized they didn't even need that crazy infinite sea model anymore. Brilliant minds like Ernst Stueckelberg and Richard Feynman proved through Feynman diagrams that negative energy is really just a mathematical trick of the light. A negative energy particle moving forward in time is mathematically identical to an antiparticle traveling backward in time. Mind-bending, right?
Which brings us right back to the very beginning of time. Breit-Wheeler pair production shows us that energy can be transformed directly into perfectly equal pairs of matter and antimatter. During the Big Bang, infinite pairs of matter and antimatter were constantly popping into existence from pure energy and then immediately smashing together and annihilating right back into energy.
Now, if perfectly equal amounts of matter and antimatter had been created, they would have completely wiped each other out. Our universe would be nothing but a boring, featureless expanse of pure energy. Yet some tiny, mysterious, mathematically beautiful glitch allowed just a fraction of matter to survive. That's 0.0000001%.
So the real takeaway of this whole explainer, the reason this mathematical autopsy actually matters, is that you, me, and everything we have ever known only exist because of a 1 in a billion cosmic rounding error. A tiny, microscopic imbalance in an equation that Paul Dirac unlocked just because he thought the math looked pretty. Which leaves us with one incredibly massive question. If we are just the 1 in a billion remainder, where exactly did the rest of it go?